Today we're doing section 1.3 day 2. We're going to be discussing even and odd functions, and we're going to be discussing how to evaluate piecewise functions. So to determine if a function is even versus odd, we're always going to be evaluating the function at negative x. So for an even function, if I input a negative x and I do all the simplifying and I end up getting the original function that what I started with, we would say that the function is even. For an odd function, if I evaluate the function at a negative x and I sit back and I simplify and I look at the result, and the result is the exact opposite sign than what we started with, we say that the function is odd. So let's go ahead and apply this to 3 examples. So here you're given the function x cubed minus 6x. So like I said, we're going to be evaluating the function at a negative x. So everywhere we see x, we substitute in a negative x. So a negative x to the third power means I would write out negative x 3 times and multiply them together. If I did that, I would get a negative x to the third power. Over here, I multiply these two, and I get a positive 6x. So notice the signs are exactly opposite of what I started with. Therefore, we would say this function is odd. For letter B, again, we're going to evaluate this function at a negative x. So I have a negative x to the 4th power minus 2 times negative x to the 2nd power. And again, it's important to use parentheses when you substitute this in. So if I wrote negative x out 4 times and multiplied them together, I would get a positive x to the 4th power. Doing my order of operations, I do my exponents over here. This will end up being a positive x squared. And then I times by that negative 2. And notice this is exactly the same as what we started with. Therefore, this function is even. Letter C is x squared plus 2x plus 1. And again, we start the same way. I have a negative x, the quantity squared, plus 2 times a negative x plus 1. So this will be a positive x squared minus 2x plus 1. So notice this sign, the first one stayed the same, the second one is opposite, and the third one's the same. So it has to be consistent. Either they all change or they all don't change. So when this happens, this would be an example of a neither. So the next thing we're going to discuss is how to determine if its function is even or odd when we are looking at a graph. So a function that is even is symmetric with respect to the y-axis. So evens are usually pretty easy to pick out when you're looking for symmetry. The odd functions are a little bit more difficult. Odd functions are symmetric with respect to the origin. So with respect to the origin. And these are a little bit more difficult to pick out. I forgot an I there. So I'm going to give you an example of each of what they look like. So for example, an even function. Let me change my pen color here so it looks a little different. An even function would look something like this. So if I folded the graph exactly in half over this y-axis, so notice if I cut it in half on both sides, it looks exactly the same. Therefore, we say that that is even. An odd function would look something like this. And the easiest way I tell students to kind of check to see if it's odd is you look at the quadrants. So quadrant 1 and quadrant 3 should have similar markings in it. Quadrant 2 and quadrant 4 should have similar markings in it. If it doesn't fall in either one of these categories, then you would say that the graph is neither. So we will go over some pictures tomorrow that I'll give you, and you'll determine if they're even, odd, or neither. The last thing we're going to discuss today, and again, all of this is a review from Algebra 2, and that's why we're kind of breezing through this, is how to evaluate piecewise functions. So Notice you have different restrictions. So this says 2x minus 1 if x is greater than 1. I have x plus 3 if x is less than or equal to 1. So we look at my input value of 3. 3 is greater than 1, therefore we're using the top equation. So I have 2 times 3 minus 1. So the answer when I input 3 would be 5. Notice you don't plug it into both, you only plug it into the one. That is a true statement. And you want to label top if you want to label that. Negative 4 is less than or equal to 1, therefore we're dealing with the bottom equation, so I'm just plugging negative 4 into the bottom equation. So the answer when x is negative 4 is equal to negative 1. Lastly, when x equals 1, we're again going to be on the bottom equation because that's where it is true. 1 is less than or equal to 1. So I plug 1 in, and the answer would be 4. All right, that's all for today.